Have you ever wondered where the artificial strawberry in your candy or the sharp banana scent in your lip balm actually comes from? The answer usually isn't fruit. Those scents and flavors are built by a specific class of chemical compounds called esters. They act as the molecular architects for almost every artificial flavor and fragrance we use daily. In the next 6 minutes, we are going to synthesize one from scratch. We will take the harsh, sour smell of acetic acid, the main component in household vinegar, combine it with alcohol, and transform it into a sweet, fruity liquid known as ethyl athanoate. Before we handle any reagents, you must prep your workspace. Put on your safety goggles, zip up your lab coat, and put on chemical-resistant gloves. We are working with concentrated acid today, so these precautions are mandatory. Safely executing this reaction provides a hands-on look at the foundational chemical bond used to produce modern synthetic perfumes and flavoring agents. Step 1. Take a clean test tube and measure out exactly 1 milliliter of absolute ethanol. Then, add exactly 1 milliliter of glacial acetic acid to that same tube. Now for the most hazardous step. Keep the test tube pointed away from your face and carefully add 2 to 3 drops of concentrated sulfuric acid to the mixture. This equation shows what happens inside. On the left, ethanoic acid and ethanol. On the right are ester plus water. Sulfuric acid acts as a catalyst, providing hydrogen ions that lower activation energy. It also absorbs water, forcing the reversible chemical equilibrium continually forward. Maximizing the final ester yield depends on actively driving this chemical equilibrium forward, a principle applied at every scale of industrial manufacturing. Next, place your test tube into a pre-warmed water bath and leave it to incubate for at least 5 minutes. Never heat this mixture directly over a Bunsen burner. Absolute ethanol is highly flammable, and exposing its concentrated fumes to an open flame poses a severe fire hazard. As hot water surrounds the glass, it steadily increases the kinetic energy of the molecules inside the tube, forcing more frequent and powerful collisions. This controlled transfer of heat acts as the engine for our reaction, driving the chemical bonding process to completion. While your mixture heats, prepare a larger beaker and fill it with 20 to 50 milliliters of room temperature distilled water. When your 5 minutes are up, use tongs to carefully remove the warm test tube. Pour its contents directly into the water beaker to quench and cool the mixture down. Now look closely at the surface of the liquid in your beaker. You will see a distinct oily layer floating at the very top. Esters are highly insoluble in water. Because they cannot mix into the lower aqueous layer, and because they are less dense, the newly formed molecules separate out and rise. This visible phase separation is your first definitive physical proof that the raw acid and alcohol have successfully transformed into a new compound. To confirm exactly what compound we synthesized, we run a sensory test. Never inhale directly over the beaker. Instead, cup your hand and gently waft the air above the liquid toward your nose. You should detect a sharp, distinctive scent. It is very sweet and fruity, often compared to pear drops, but it carries a strong undertone of chemical solvents, the same characteristic aroma found in a fresh bottle of nail polish. The presence of the oily layer and that unmistakable sweet scent confirms your esterification worked. You have just successfully replicated the standard bench chemistry used by professional flavor developers. We can also run this chemical reaction in reverse. If you take an ester and react it with a strong base, like sodium hydroxide, instead of an acid, the molecule is forced to break apart into an alcohol and a sodium salt. This reverse reaction is called saponification. When applied to specific fats and oils, it forms the salts and alcohols required for industrial-scale soap manufacturing. Understanding esterification and saponification allows us to manipulate the same molecular bonds to create both fragrances and essential hygiene products. With your results verified, you can now safely dispose of your mixture and clean your glassware.